Hi guys! So today we're going to talk about definite integrals. So definite integrals, that's when we start to look at actual values, find the actual area between a curve and the x-axis, not just, well, once we plug some values in, this is what it would be. So the first way to find it, the easiest way to find it is with your graphing calculator, or your graphic display calculator. So if you are allowed to use a calculator on a test, keep it close and handy and do all of your work on there. There's no point in doing it by hand. Today we're going to go through and practice everything by hand, and then we'll double check our answers using our handy dandy calculator. So here's what we're going to do. First of all, we're going to go to y equals, push that button right there, and then we're going to go ahead and put our function in. So we'll have x squared plus 1 for our function. Then once we're there, we'll press second and then trace to get to calc. And then we'll go down and choose 7 where it has the integral of f of x. So you can press 7, you can boop all the way down, you can press up, whatever you need to do. Then it'll graph and then it'll give you a little message. So the first thing it says is, what's the lower limit? Now it's going to, you might be tempted, especially when you found minimums and maximums, you went a little bit to the right and then a little bit to the left. Right now all you have to do is just enter in a number. What's your lower bound? 0. So I'm going to put in 0 and press enter, and then it asks for the upper limit, and my upper limit here is 2, so I'll just press 2 and then enter, and then it'll think, and then down there at the bottom, that guy right there is my answer, 4.66666. So 4.6 repeating. So hi Peanut. Oh, okay. Apparently we're cuddling. All right, so what's the area between those two curves? My answer is going to be 4.6 repeating. Good deal. Okay, cool. All right, so now let's go ahead and look at how do we figure out a definite integral by hand. So finding the definite integral by hand is actually called the fundamental theorem of calculus. So if we have the integral from a to b of a function, what we're going to do is we're going to take the integral of that function to get this f of x. So this is my integral, and I just assume, that c is 0. And then I have my lower bound and my upper bound. So I plug my upper bound into my integral and subtract my lower bound substituted into my integral. So it's a little bit of tedious work, but it's really not too bad. So let's try a problem. So we want to find the integral of -2 to 1 of x minus 1 dx. So the first thing we need to do is find out what is the integral of this guy. So I need to take the antiderivative of x minus 1. So I need to add 1 to my power and divide by my new power. So that's why I have x squared over 2 minus, and then the derivative that would give me 1, that would have had to be x before this. So that's x. And then technically, like we said at the end, we usually have a plus c on there, right? What we're going to do for all of our definite integrals is we are going to assume that c is 0. So you don't have to write out that plus c every time. If it's an n definite integral like we were doing before where it didn't have certain bounds, you need to have a plus c on there. For here, when we do have bounds, you don't need the plus c. So now I need to take this integral that I have, x squared over 2 minus x, and I'm going to get ready to evaluate. I have -2 as my lower bound and 1 as my upper bound. So here's how we'll go through and solve. First, we'll take our integral and we'll plug in my upper bound, which is 1. So I'll have 1 squared divided by 2 minus 1. And then from that, we'll subtract my lower bound plugged in. So negative 2 squared over 2 minus negative 2. And now we'll just go through and do a little bit of math. So I have 1 squared is 1. 1/2 minus 1/2 is negative 1/2. Minus, and then let's see what's going on over here. So negative 2 squared is 4. 4 divided by 2 is 2. And then I have 2 plus 2 is 4. So I have negative 1/2 minus 4 gives me negative 4.5 for that integral. So that's my answer. Now let's see if it's right. So what I'm going to do is I am going to go back to y equals and put in x minus 1 for my function. Second calc, 7. And there's my function graphing. My lower limit is negative 2, enter. Upper limit is 1, enter. And if we look right there, we get negative 4.5. So we're correct. Yay! Okay. Here we go. Next one. We have the integral from 2 to 3 of 1 over t dt. So the first thing we have to do is we have to figure out what is the antiderivative of 1 over t. The antiderivative of 1 over t is the natural log of t. And then technically plus c, right? But we don't have to worry about that right now. And then we need to evaluate from 2 to 3. So now we have to go ahead and plug that in. So I'll take the natural log of 3 minus the natural log of 2. Now you might be tempted to leave it like that, but I want you to remember how we expanded and condensed logarithms last year. If you remember, when we subtracted the logarithms, that meant that we were supposed to divide the stuff that's inside of the logarithm to make it one logarithm. A lot of times they only want the most exact answer instead of something like this. So a better answer here would be the natural log of 3/2. And that would be my answer. So we can go through and check that again, but it's not going to show up as the natural log of 3 over 2. Of course, it's going to give it to you as a decimal, so you'll have to go back and double check that the natural log of 3 over 2 does match that decimal. Okay, let's keep on trucking. So now we have the integral from 1 to 3 of hi puppy of 4x squared times x minus 1. So what we might be tempted to do right now, hi pupper, is to think about trying to use a u substitution that we could cancel something out for, but that's really not that's really not going to happen. So the best thing to do to get this into a better thing to integrate is to go ahead and simplify that x squared on out. Isn't it, puppy? Yeah, that's best. That's best. So this is going to be the same thing as the integral from 1 to 3 of 4x cubed minus x squared, or 4x squared dx. Okay, so now we'll go through and take the antiderivative. So we need to add 1 to the power, divide by the new power. Add 1 to the power, divide by the new power. And then technically there's a plus c right there because I want to clean things up real quick. So these 4's right here, they'll divide away. So I'm left with x to the fourth minus 4/3 x cubed. And then we need to evaluate that from 1 to 3. So first thing we'll do is we'll plug 3 in to that guy. So we'll have 3 to the fourth power minus 4/3 times 3 cubed. I'm going to flip through my notes so that way I don't have to figure out what that is. Ugh, that sounds gross. So if I were to put, let's come back to you. Minus. And then we're going to plug 1 in over here. So now we have 1 to the fourth minus 4/3 times 1 cubed. Okay, now, right now we could go through and do a whole bunch of math and try to simplify and all that sort of stuff, but will you just trust me that it turns out to be 136 thirds? It does, I promise. Okay, now let's take a look at this guy over here. So, I have the integral from 1 to 5 of e to the 2x plus 1 over x squared. So we're going to tackle each of these antiderivatives separately. So first we're going to look just at this e to the 2x. So first of all, we have to remember what's the integral of e to the x. That's e to the x. That's going to stay the same. But if you remember, if I have something linear up there, if I have something multiplied by my x, I need to account for that by having 1 over that value out front. So I have 1/2 e to the x for the first part. Now remember, 1 over x squared is the same thing as x to the negative second. So what we're going to have to do to take the antiderivative is add 1 to the power, so now x is to the negative first, and divide by the new power, so -1. Now I'm going to clean this up a little bit. So what we have right now is e to the 2x over 2 minus 1 over x. And then we are supposed to evaluate that from 1 to 5. So the first thing we'll plug in is that 5. Let me wiggle down a little line of demarcation here. Hi, Peanut. So we'll have e to the, all right, now 2 times 5 is 10 over 2 minus 1 over 5. Oopsies, not x, 1 over 5. There we go. Goodies, right? All right, and then we will plug in 1. So we'll have e to the second, because 2 times 1 is 2, over 2 minus 1 over 1, or just 1. And if we want to go through and simplify that more, or if you put it into your calculator, or we can just leave it like that. I think I would just rather leave it like that. You could also have it as e to the 10th over 2 minus e squared over 2 plus 4/5. That's an option as well. Okay, let's keep on going. So, on this first one, we want the integral from -1 to 1 of 2x minus 3 to the third power. So remember, when we have something linear inside of a function like that, that value in front of our x is our a value. So when we start to take the integral, we need to have 1 over that a value times. And then I need to make sure that I add 1 to the power, so that's going to be 4. And then I divide by the new power, which is 4. And I can keep that 2x minus 3 on the inside right there because I took care of that being another function with this over 2 outside. That's 3. And then technically there is a plus c. I'm going to go ahead and clean this up a little bit so it might be a little bit easier to evaluate here in a minute. So if I multiply my numerators together, I end up with just 2x minus 3. And that'll be to the 4th power. And then multiply my denominators together. So that will be over 8. And then I need to evaluate from -1 to +1. So what we're going to do is we're going to plug in our upper bound first. So if I plug in +1, I have 2 times 1 minus 3 to the 4th power over 8 minus, and then I can plug in -1. So I have 2 times -1 minus 3 to the 4th power all over 8. Okay, so 2 times 1 is 2. 2 minus 3 is -1. -1 to the 4th power is +1. So I have 1/8 there. Minus 2 times -1 is -2. -2 times -3 is -5. So I have -5 to the 4th power over 8. Now when we go through and simplify this, just trust me, it ends up being -78. Okay, now let's take a look at this next one. So it's going to work kind of the same way. What might be helpful is to rewrite this as the integral from 0 to 3 of 3x plus 16 to the 1/2 power instead of the square root dx. Okay, so the next thing we have to do is we have to remember that since we have something linear on the inside, just like we did over here on E, we have something linear on the inside. So that means that 3 is going to be my a value. So that means when I take the integral, I need to have 1 over 3 times. And then we have 3x plus 16. I need to add 1 to the power, so 1/2 plus 1 is 3/2. And then we'll divide by the new power, which is 3/2. And then plus c. So now I'm going to go ahead and clean it up a little bit. I need to multiply by the reciprocal since I'm dividing my fraction, so I'm going to flip it over. So I have 1/3 times 2/3 times 3x plus 16 to the 3/2 power plus c. And then I'll clean it up a little bit more. I'll get 2/9 3x plus 16 to the 3/2 power. And now we need to evaluate from 0 to 3. From 0 to 3. Okay. So the first thing we have to do is plug 3 into that. So we'll have 2/9 times 3 times 3 is 9 plus 16 to the 3/2 power. Minus, and then we'll have 2/9. Let's see, when we plug in 0, 3 times 0 is 0. 0 plus 16 is 16 to the 3/2 power. Now if we go through and simplify just a little bit more, add those together, take a square root, and then cube it, and blah, 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 blah. After all of that, we end up with 122 ninths for the area underneath that curve. Okay, one more. Oof, this is kind of gross. So we have the integral from 0 to 1 of 2x squared plus 1, that quantity cubed, times 4x. So this isn't linear, so I can't just put 1 over a and take the integral and go on from there. But the derivative of 2x squared plus 1 is 4x. So if I do a u substitution, I'll be able to cancel out that 4x. So here's what I'm going to do. I'm going to go ahead and say that u is equal to 2x squared plus 1. All right, so then we have du equals 4x dx when we take the derivative of both sides. And now we'll solve for dx. So we have du over 4x equals dx. So now we'll substitute in what we can. So right now we have the integral from 0 to 1 of u cubed times 4x, and I'm going to put that over 1. And then I can rewrite dx as du over 4x. So here's what we've got right now. My 4x's can cancel out. And now I just have the integral from 0 to 1 of u cubed du. So now we'll take the integral. So remember, I need to add 1 to the power and divide by the new power. And technically that has a plus c on there. Before I go back and evaluate, I'm going to plug in what I had for u. So we have 2x squared plus 1, and that was to the 4th power, over 4. And now we'll evaluate from 0 to 1. So when I plug 1 into all of that, let's see, 1 squared is 1, 2 times 1 is 2, 2 plus 1 is 3. So I have 3 to the 4th over 4 minus, and then if I plug in 0, 0 squared is 0, 2 times 0 is 0, 0 plus 1 is 1. So we have 1 to the 4th power over 4. And then if you go through and you figure out what 3 to the 4th is, divide that by 4, subtract a 4th from it, you're going to end up with 20. All right, tomorrow we'll practice a little bit more, and then we will look at the area between two curves. Have a great day. Bye, guys.